Part 3, Consensus Building in SLA, a Proposed Framework. Chapter 6, Towards a Tailor-Made Definition of Consensus for SLA. Consensus over the facts versus consensus over the fundamentals.
The origins of Kuhn's term paradigm can be traced to his bewilderment over the differences between the natural and the social sciences.
Both history and acquaintance made me doubt that practitioners of the natural sciences possess firmer or more permanent answers to legitimate scientific problems and methods than their colleagues in social science. Yet somehow the practice of astronomy, physics, chemistry, or biology normally fails to evoke the controversies over the fundamentals that today often seem endemic among, say, psychologists or sociologists. Attempting to discover the source of that difference led me to recognize the role in scientific research of what I have since called paradigms.
Kuhn, 2012. XLI. The thesis I put forward here and attempted to defend and demonstrate in the third chapter is that what SLA needs is the forming of a paradigm that is a set of agreed-upon fundamentals about language and acquisition development as a unified interpretative framework to be used in cases of disagreement. That is, of course, for the scientific side of SLA, in contrast to what has been defended as purely applied pedagogical issues. See Chapter 5. Pedagogical research may be useful for the benefit of educational audiences as conducted in a theory-exclusive or even theory-free manner, mostly for instructed learners of English. However, consensus over particular facts cannot happen in any scientifically valid way when findings are interpreted through clashing ontologies and epistemologies, and much less when they even lack them. As I have been insisting, falsifiability cannot be a functional criterion in a pre-paradigmatic science, as the determination of which tests have resulted in falsification, and which in corroboration is conditioned by clashing theoretical stances. That is not to say falsifiability should not be a quality of theories, it probably should. So instead, what I propose in Chapter 9 is a model of social falsification, where clashing parties take steps to agree on research designs and pre-negotiated standards of interpretation. Disagreement over the fundamentals is perfectly valid, but not as a permanent state of disarray. The moment there is disagreement about the fundamentals, all factual evidence becomes relative to the theoretical preference of the observer, which creates strong divides among scientists. This is neither a functional science nor an informative one, most definitely not an efficient one. And this has important consequences for the scientific integrity of a field, for the ethical allocation of limited funding, and for the plausibility of a positive impact of research findings in the world's problems. A forced division between fundamentals and facts needs further elaboration. Of course, theories need testing, and theory testing is a kind of fact-checking. However, the kind of facts that are looked for when testing a theory of fundamentals address ultimate questions that have conceptual consequences for more superficial levels of analysis. Questions such as, what is a language L1 or L2? What is proficiency? What is L2 acquisition development? What is the source of stability in multilingual linguistic systems? What is the source of variability in multilingual linguistic systems? How can these be described or measured? And so forth. Not questions like, does corrective feedback lead to better writing? Partly because what a theoretical framework can provide is plausibly accurate ad hoc explanations for why corrective feedback could or could not lead to better writing in the first place, in which ways, through what mechanisms, and under which conditions, along with multiple other accurate explanations well outside of the realm of L2 pedagogy and education. Ultimate questions, to actually be ultimate, cannot focus on instructed learners, but on all humans, all contexts, all needs. This is the reason why I argue a basic science is not only more comprehensive but also more equitable.
Consensus as a PR stunt versus informed agreement.
In Chapter 2, I offered examples of theories being misconstrued when they are applied outside of the social groups where they originated or where they were put forward. And I discussed that the existence of social groups divided roughly by theory leads to a lack of communication, mutual understanding, as well as to systemic epistemic exclusion of non-English speaking people and non-native English speaking theorists that could represent diverse communities around the world, which would lead to open theory being a priority for open science in SLA and applied linguistics. One of the implications of this information is the risk of either adopting or rejecting theories while holding misconceptions of such theories, something we could label uninformed disagreement. Another potential risk is the rapid adoption of a theory on non-scientific grounds, such as the raw number of researchers who adopt it, the originality of the theory, or it representing a fashionable epistemic trend. Ali Al-Houri and Phil Hiver indeed have alluded to this risk when they caution us against opportunistic uses of CDST Hiveramp Al-Houri, Hiver et al. What these scholars argue for is a proper application of their preferred meta-theoretical framework. I would add that in the context of consensus building, a theoretically rigorous application of the principles of a theory is not a sufficiently valid criterion for its widespread adoption. Since scientific disagreement takes place a step back, in the clashing fundamentals of all theories, this would need to be the focus in choosing one theoretical framework over another. When consensus is not formed through collaboration between members of rival theories, we risk a kind of widespread adoption based on superficial incentives. If we take the raw number of researchers that adopt a theoretical framework, i.e. fame, as a sign of consensus, even if they properly understand and apply the theory, what we get is a kind of consensus that can be better understood as a PR stunt. Because this would end up being a dismissal of rival theories, not through acknowledgement of the well-informed opposition, and the testing of plausibly existing flaws, but through theoretical preference alone. We must remember, all theories claim productivity and success, all claim to have good evidence. If suddenly we see a shift, where many researchers adopt a theory, and they point at the evidence alone, as a valid justification, this leaves the regulatory function of pluralism out of the picture. Widespread theoretical preference is thus a risky criterion for consensus. And it is not what I advocate for in this book. The same goes for the rejection of a theory. It cannot be based on superficial factors, such as the particular theory in which a particular person was trained on, our theoretical identity, or the evidence produced through our own theory, but on a deep understanding of rival theories, and on collaboration and serious criteria to test and evaluate the particular theories involved in a disagreement. The importance of consensus building is thus not in the consensus, but in the building, not in the agreement, which by itself seems to be epistemically meaningless, but in the intricate process of trying to reach an agreement.
Consensus is revisable, not an event, but a sustained process.
Many philosophers of science see disagreement and criticism as crucial elements for scientific progress. For example, Boumans and Martini, 2014, or Eskes, 2019, with very few exceptions, such as manufactured disagreement, or Eskes and Conway, 2011. Failure to recognize objections and move from original positions, Feyerabend, 1999, Chal, and also, even if in rare occasions well-merited stubbornness, Santana, 2021. Outside of these kinds of toxic disagreement, all disagreement has the potential to refine science. This includes the fundamental questions too. Consensus does not need to be, or in fact could ever be, a single moment where everyone looks at the research, talks things out, agree on everything, and the agreement stays forever. In fact, this is an unfortunate caricature. Rather than that, consensus needs to be a constant process of epistemic coordination, where consensus statements can be made, with the condition that they are revisable and periodic, because science is inherently revisable. Building or adopting a paradigm would not take a few international conferences, but rather, a systematic effort that may span several years. A second kind of consensus over the facts, may also take time to be coherent, that is agreed or contested, through a single set of fundamentals, not to mention, even once it is coherent. Agreeing on particular facts may still be a centuries-long epistemic endeavor, as it is for the rest of the sciences. Not agreeing on all facts seems to be the natural condition of science, which allows it to change and evolve over time. Disagreement over the facts is not the problem, but rather the lack of a set of fundamentals that allows us to put forward coherent arguments as to where we disagree in the first place, and that enable an empirical process of collaboration towards an agreement. Finally, a third type of consensus over best practices in the application of science, not limited to L2 pedagogy, will probably remain as general suggestions, because decision-making of these kinds no doubt will forever remain as an art, rather than a science, as this is highly dependent on contexts, conditions, plausibility of application, available means, specific needs, values of communities, political divisions within the communities, leadership, as well as level of knowledge and authority of decision-makers. All of us, teachers who have attempted to innovate teaching practices in institutional contexts, are very aware of these limitations, and we can only imagine how this could apply in more important contexts, such as in policy-making, where the quality of life of more people, often minoritized people, is at stake. In other words, once an intra-scientific consensus has formed, good luck convincing anyone outside of academia, especially when decision-making is, of course, extremely constrained by political forces. Politics often defines the distance between science and its application. In fact, Collins and Evans 2007 discuss the need to demarcate science from politics, p. 125. One of their key statements is as follows.
Democracy cannot dominate every domain. That would destroy expertise, and expertise cannot dominate every domain. That would destroy democracy.
Collins and Evans 2007, p. 8. When theories, evidence, data, and technical expertise are the only basis for decision-making, we devolve into a technocracy, see Evans 2014, which is most definitely not what I would advocate for. On the other hand, when we allow political forces, either authoritarian or democratic, to govern decision-making, then science can get seriously mischaracterized to advance the agendas of people in positions of power, or to fit the needs of a community. There is thus a permanent need to balance these two opposing forces. For that purpose, Evans 2014 proposes participants on either side require protection. Decision makers are protected when we understand
A strong technical consensus does not restrict the policy choices available. What it restricts is the reasons that can be given in order to justify them.
P2. Technical experts, correspondingly, are protected when technical advice is accurately portrayed. P250. Evans further clarifies. In order for science to be accurately portrayed, decision makers should not justify actions and choices by citing certain experts, while ignoring others, thus creating a false impression of agreement. Evans, 2014, p. 251. Not only that, but he also warns that in practice the political usually dominates the technical. His hope, then, is that decision makers at least do not distort science. A so-called applied field exists in an awkward middle position, where truth has to be negotiated, not only through clashing scientific views, but also by taking into consideration the urgent demands of communities. One could argue, if sustained negotiation is needed anyway, why not agree on theory and practices simultaneously and indiscriminately? However, what is considered to be plausibly true from a rigorous scientific perspective, and what is helpful according to perceptions within communities are two very different things. In other words, we should be very careful to distinguish science-making from decision-making. Both do require sustained negotiation, but to achieve completely different goals, through completely different criteria. Consensus building is thus here conceived as 1. Building agreement over fundamentals before facts, 2. Building agreement through a deep understanding of opposing theoretical frameworks, 3. Building agreement while going beyond the needs of overrepresented minorities, and 4. A sustained process of revisable agreement. There have been some significant attempts at epistemic coordination in our field, for example, Holstein et al., 2015a, and the Douglas Fir Group, 2016. These are incredibly important efforts in our field. However, they do not meet all of the 4 criteria mentioned above.
Summary of propositions in Chapter 6.
There is a difference between agreeing on facts and agreeing on the fundamentals on which those facts rest. Falsifiability is not a functional criterion when fundamentals are unsettled, as there are diverse criteria for what constitutes successful falsification. As such, SLA is in need of a theory of fundamentals, rather than agreement over particular facts. Ultimate questions, to actually be ultimate, they cannot focus on a multilingual minority, but on all humans, contexts, and needs. Due to the existence of thought collectives and the lack of open theory, there is a risk of agreement and disagreement being caused by incomplete knowledge of theories. Widespread theoretical preference is a risky criterion for consensus, because it leaves the regulatory function of pluralism out of the picture. The importance of consensus building is not in the consensus, but in the building. Disagreement is crucial for scientific innovation to occur. Building or adopting a Kuhnian type of paradigm may take a long time, but the establishment of facts depends on a common framework to interpret them. Consensus is not a moment when truth is established, but rather a process of epistemic coordination and negotiation that will be as ever adaptable as science itself. Because best practices are constrained not only by SLA's facts but also by socio-political factors within communities, agreement at this level has to remain as general recommendations.